And turn on captions. Okay. Today we're going over sum and difference identities. I think it's this one. Yeah. So let me make sure. Yeah, that's the derivation. That's the derivation. And there they are. So I want you to go ahead and write these down. This is called sum or difference. You should have sine. Hold on. They're doing cosine first. I don't see sine. Yeah, they're going to do, okay. Just making sure. There is the cosine. Sum or difference, cosine. They're supposed to be sine, but I don't know where they got them on these slides. So you might want to write those down. Cosine of A minus B is equal to cosine of A. I say cos, sine, sine. And cosine of A plus B is cos minus sine, sine. So however you want to memorize them is fine. I know there's no learning this, okay? You're going to have to memorize some of these identities. And cos plus sine, sine, and cos minus sine, sine, that's the way I remembered them. So you can do whatever you want to, but that's how I remembered them. And we'll do an example here in just a second. Find the exact value of the following. I'll write it down for you. Find the exact value of cosine of 15 degrees. Find exact value of cosine of 15 degrees. And this is what a test question will look like. And you basically find that'd be 30 and 45. That's what you could do 30 and 45, which would be 45 minus 30. Why did I say 45 minus 30? Because that's our special angles. So chances are you're going to use 45 over 30. So when you're talking about the sum and difference angles, you're talking about a combination of your special angles. So I'm going to go ahead and write this. Cosine of 45 minus 30. You could do cosine of 60 minus 45. You could do those two. I can't write and do this at the same time. So I'm just showing you the slides, and we'll work the problem as we go with the slides. And there is their 45 minus 30, or 60 minus 45, excuse me. So you're going to use cos minus sine. I don't know. I'm going to pick 45 and 30. They're smaller numbers. I don't know what the slide's going to pick. But I would pick 45 minus 30. So I would say cosine of 45 degrees minus 30 degrees is equal to cos minus sine. And put in a 45 and a 30 and a 45 and a 30. There you go. Now, we all know that the cosine of 45 is square root of 2 over 2. So that's going to be the square root of 2 over 2, square root of 3 over 2, minus square root of 2 over 2 times 1/2. And now all you got to do is finish it. I think y'all can finish it. So I'm going to let y'all finish it. That right there is a test question. I'm not going to try to, I don't know what to say. I'm not going to try to confuse you on this test. I want you to be able to use the identities, and I want you to be able to convert using the identities. I do not want you to memorize every single identity. That's why I give you that cheat sheet, and I told you to use it. All right, what y'all get? The square root of 2 times the square root of 3 is square root of 6 over 2 minus the square root of 2 over 2. I'm sorry, 4. And the square root of 6, that's going to be equal to the square root of 6 minus the square root of 2 over 4. That's what I got. Be plus, I'm sorry. I did. It's supposed to be plus, sorry. Now that is a test question. Please don't make it harder than it is. That's it. And next. All right, you try this one. Find the exact value of the following. Now, I would find out where I am, and then I would just use that. But you do what you want to. 5 pi over 12. So 5 pi over 12 is what? Well, 5 pi over 12, if you want to find out where you are, 5 pi over 12 times 180 over pi. Pi's cancel. 12, 6 will go in there 2 times. 6 will go in there 30 times. 2 will go in there, wait a minute, yeah. 2 will go in there 1 time, 15. 15 times 5 is what, 75? So 75 degrees. So what is 75 degrees? 30 plus what? 45. Now you could easily do 30 plus 45 and come out with the same answer. So that's what I'm going to do. I'm going to do that right here because I know that cosine of 30 or 45 plus 30 is going to be equal to cos minus sin. 45, 30, 45, 30. Then back to the PowerPoint. And that's what they did. And that's going to be minus, and that's going to be square root 3 over 2. Yeah. Over times square root 2. I got mine backwards. So I've got square root of 2 over 2 times square root of 3 over 2 minus 1/2 times square root of 2 over 2. And that's going to be the square root of 6 over 4 minus square root of 2 over 4, which is the square root of 6 minus square root of 2 over 4. And it should be the answer. Yep. Negative square root of 6 minus square root of 2 over 4. And that's another type of test question I would give you. As you can see, some of them are not that difficult. Okay, here's one. Wait a minute. Okay, here's one that says, write cosine of 180 minus theta. This is when you don't finish it. You just simplify it. So I would give you this problem on a test, and I'd say rewrite as a trigonometric function. Well, that's cos minus, so that's going to be cos plus sin. So cosine of 180 minus theta. Well, I can tell you right now that's going to be cos sin. And of course, 180 minus theta, you're going to get 180 in theta. So that's cos of 180 and theta, and the sine of 180 and the sine of theta. There it is. Cosine of 180 times cosine of theta plus the sine of 180 plus the sine of theta. And now you just finish it. The cosine of 180 is -1. Plus the sine of theta is 0. Sine of theta. Well, the 0 sine of theta goes away, and you're left with negative cosine of theta. Now, this one is not solvable. You can only get it down to the cosine of theta. So you need to make a distinction in your notes that this one You don't get it down to an angle or a exact. It's just cosine of theta or negative cosine of theta. All right. And sometimes you can use the cofunction relationship and letting theta equal a plus b. Now, I probably won't ask you that, but I want you to go ahead and write it down. And this is how we get our sign. This is how we get our sign of the plus and minus identities. So this is kind of a derivation. You don't have to write it down. But as you can see, sine of a plus b is going to be sine cos cosine sine, or sine cos cos sine. However you want to memorize it. Let me just bypass this right quick. There you go. So the sine of a plus b is equal to sine cos cos sine, and a minus b is sine cos minus cos sine. Now you don't have to memorize the sign because the sign goes with the identity. Plus, plus, minus, minus. Now to me, this one's the easiest to remember because which way do we read? Left to right. So sine of A, sine of B. Cosine, sorry. So there it is. It's pretty much linearly. And you also got the plus and the plus. To me, this one is the easiest one to remember out of the sine, cosine, or tangent. And you use it the same way that we used the last one. In other words, 45 would be, or 15 would be 45 minus 30, or 60 minus 45. And then use your special angles to crank out the math. You're awful quiet today. What is it, Monday on Tuesday?
I overslept.
You overslept.
Yep.
I'm sorry.
That's okay. I'm here now.
So, and the tan over 1 minus tan. Tan over 1 plus tan. Now, I know I sound goofy saying that, but that's the way I memorized it when I was a student. And the signs match the top and the opposite on the bottom. So tan 1 minus tan 1 plus tan. And like I said before, I'm going to give you questions on the test that are pretty much plug and chug. I'm not going to ask you to reinvent the wheel, and I'm not going to ask you to come up with an O-ring for the space shuttle, okay? I just want you to be able to memorize the identities or use your cheat sheet and manipulate them. In other words, solve for whatever you can solve for after you plug and chug. That's all I'm asking. So let's go with the sine of 75 degrees. A will be the sine of 75 degrees. That's a test question. The tangent of 7 pi over 12. And that's probably all I would give you on a test. They got a third example, but I probably would not do that one on a test, but we'll look at it after. So there is your 3 examples. So I want you to try to do the first 2. Try to do the first 2, A and B. Give y'all 5 minutes to work on A and B. As I said, the first one, A, I'm going to use the sine of 45 plus 30. And that'll give you sine, cosine, and remember, the plus carries plus cosine, sine. So I remember it as sine, cosine, plus cosine, sine. So that's going to be the sine of 45, cosine of 30, cosine of 45, sine of 30. And the sine of 45 is the square root of 2 over 2 times the square root of 3 over 2 plus the square root of 2 over 2 times 1/2. And that's going to give you the square root of 6 over 4 plus the square root of 2 over 4, square root of 6 plus square root of 2 over 4. All right, 7 pi over 12. I don't deal with 7 pi over 12, so I'm going to multiply by 180 over pi. And that's going to be 6 will go in there, 7 over 2 times, I'm sorry, 6, that'll be 30 over pi. 15 times, what is that, 105 degrees? Somebody help me out.
Yes.
Okay, so 105 degrees is 60 plus 45, right?
Yep.
So tangent of 60 plus 45. Well, that's tan over 1 minus tan. Tan over 1 minus tan. Because I know this sign is opposite of this sign. All right, that's going to be what? The tangent of pi over 3, or the tangent of 60. Let's go with the tangent of 60 over the tan of 45. 60 and 45. That's going to be the square root of 3. And that's going to be plus 1. Sorry. Over 1 minus the tan of 60 is what? Square root of 3. And the tan of 45 is 1. Square root of 3 plus 1 over 1 minus square root of 3. Well, this is going to be 1 minus square root of 3. This is a radical in the denominator. So you're going to multiply by the conjugate. And the conjugate of 1 minus square root of 3 is what? 1 plus square root of 3, Hubert. And that's going to give you shortcut number 3 on the bottom. And the FOIL method on top. Square root of 3 times 1, square root of 3. Square root of 3 times square root of 3 is 3. 1 times 1 is 1. And square root of 3 times square root of 3 is square root of 9, which is 3. Y'all check my algebra. And then 1 goes here, and the square root of 3 goes here. That's first for square root of 3. Yeah, 1 times square root of 3. Yeah. And that's going to be 1 plus square root of 3, 1 plus square root of 3. That's 2 plus times square root of 3 plus 4 over 1 squared is 1, and square root of 3 squared is 3. 1 minus 3 is negative 2. And you can factor out a 2. That'd be the square root of 3 plus 2. I think that's right. Yeah. And this would be a negative 2 down here. That would cancel. I got negative square root of 3 minus 2. What'd y'all get? Thumbs up, thumbs down. And nobody says anything. Now that's 2 test questions I could give you with sine and tangent. And a lot of people say, well, Hubert, when is anybody ever going to walk up to me and ask me? Nobody's ever going to walk up to you and ask you to manipulate sine of 75 or tangent of 7 pi over 12. Nobody's going to walk up to you at a construction site and ask you that. Nobody's going to walk up to you in a mechanical engineering office and ask you that. But will you be asked to manipulate problems, take them apart, and put them back together? Yes. And if you don't have the critical thinking skills to do that, it's kind of like you can't work a doorknob if you've never had any math. You don't know how a doorknob works. You got to be able to manipulate problems. I mean, think about it. Women have been doing it for years, right? I didn't say that. Oh, I can't believe I said that. And nobody says a word. I said women's been doing it for years. Whatever. Where's all my videos? I only got 9 people. And there's like 13 videos. What the hell? I guess y'all just quit videoing, right? Make sure I got my, oh, I know why I don't see y'all. I don't have the large gallery on. Okay, forget I just said that. Everybody's got theirs on. I'm sorry. I suck. I don't have mine on. Damn. I'm a hypocrite.
If you don't see mine.
I'm sorry, what?
If you don't see mine, it's because it keeps turning off. I don't know why.
Who was that, Miss Hernandez?
Yeah, that's me.
No, you're good. I'm just looking to see where, darn, Miss Croxton looks like she's in a church or something. Where are you, Miss Croxton?
In my room.
Oh, well, you look like you got a big mosaic window behind you.
No, it's one of them mandala things.
Okay, yeah, you go, girl. All right. Next question. Now, I think they were asking a third question, and I'm not going to test you on that, but I think the third question was the cosine of 40. I'll write that down. Cosine of 40 degrees, cosine of 160 degrees, minus the cosine of 40 degrees, sine of 160. And in this case, you're going bass-backwards. Okay? You got cosine, 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 sine. I've got one of them messed up. Sine. Supposed to be the first one, supposed to be sine. Sine, cosine, cosine, sine. Now I want to back up, and I want you to tell me what sine, cosine, cosine, sine with a minus. Let's go back. Sine, cosine, minus cosine, sine. Here it is right here. Sine 40, cosine 160, minus cosine 40, sine 160. So A is what? 40. So that's going to be sine of 40 minus 160. And of course, sine of negative 120. Oops. And that should be, and of course, sine of negative 120 is negative 3 over 2. Sorry. Square root of 3 over 2. Question, gripe, complaint. I'm trying to find one that I'll test you on. I've been giving you several that I would test you on. Okay, here's one I would test you on. See if I can get it to work right. All right, try that one. They already put it in. They put it in there for you. Cosine of x minus pi over 2. Well, of course, that's 90 degrees. You can put 90 degrees if you want to, because you'd be able to do it a whole lot faster if you think of it as 90 degrees. So cosine of x minus pi over 2 is cosine of x minus 90. Well, that means we're going to use cosine minus cosine of a minus b, cos plus sine sine, cos plus sine sine. X 90, x 90. All you got to remember is your unit circle. What's the cosine of 90? What is the first digit in the unit circle at 90 degrees? 0. Yes, that's right, class. Cosine of x times 0 plus the sine of x. And what is the first digit or the second digit for the sine of 90?
1.
Hubert?
1.
Thank you. So your answer is what? Sine of x. That's the type question I would give you on a test. So you have 2 type questions that I will give you on a test. I will give you this is 6.2, or I'm sorry, 10.2. I will give you a 45 minus 30 type question, and you do the sine, cosine, or tangent, whatever they ask you for, identities, sum identities, sum and difference. And then I will give you something like x minus pi over 2. And you would do either the sine, cosine, or tangent, sum and difference identities with 2 numbers or with 1 number or 1 angle. And that's basically, now you got to remember to do one thing. You got to remember at the end to use your special angles after you get it all worked out, and to leave in terms of radicals, meaning exact. Okay? Now, those are the two type questions I would give you. So what I would do is I would make me an index card. I'd go to the handy dandy sum and difference entities. And I would try to find, here they are right there. There's a good one right there. And I'd put that on an index card right there. Copy. And I'd go to my handy dandy word processor. And I'd control V. And I'd make it a little bit bigger. And I'd print that out, and I'd do my 6.2 homework just with that card right there. Because all you're going to be doing is plugging and chugging, using your special angles, and reducing your answer in terms of a radical. So if you really think about it, which one's more difficult? 6.1, I mean 10.1 or 10.2?
10.1.
Me personally, I think 10.1 is more difficult. Because 10.2, you're just plugging and chugging. And nothing. Yeah, Hubert, I would agree with you. No, Hubert, I would disagree with you. No, we're just going to sit here and stare at you and not talk. Why do y'all do this to me? Do you hate me? Mr. Thornton, you don't hate me, do you? He ain't gonna talk to me. That's all right.
No, I don't hate you at all.
Well, why do y'all treat me like this?
I don't know what.
Just say it's your way, right? What is it? What are y'all called? Degeneration Z or something?
No.
It's y'all's way not to communicate.
No, I don't even know what my own generation is called.
What your generation is called Generation Z. I'm Generation X.
Learn something.
The 80s, grew up in the 80s, the best music, the best TV shows, the best movies. It was just all the way across the board. Okay, nothing. Okay. I'm beginning to give up. Let me see if I can find another. Ooh, there's one. I like that one. Ooh, spam risk. I'm looking. Yeah, that one could be. I guess it could be, but I don't think so. I'm looking to see if I can find another one. That's it. Okay. Let's see what identities are in the next section. 10.3. Because remember, my job is to confuse you and discourage you. So let's see what we can get into in 10.3. Since nobody's talking, we'll just keep moving on. Maybe that's what I need to start. You know what I'm thinking about doing? I'm just going to start writing and not talking. How about that?
No.
Since y'all do it, y'all write and not talk, I'll just start writing and not talking. What do y'all think?
I usually talk. I just started back to work this past week and I'm exhausted. And yeah.
I'm talking about the rest of the class, Miss Croxton.
Well, why
I know you talk. The rest of the class, they sit there like a tit on a bull.
I'll
They do absolutely nothing. They don't communicate. Maybe one or two of them does. Miss Hernandez, she's about to fall out. I mean, I can't win.
I'll say this. I was always taught it's better for people to think you're a fool than open your mouth and prove it.
Oh, yeah, well, my grandfather used to say, if you don't open your mouth, you won't show your ignorance. But in my case, when I want somebody to talk, I want the class to talk. But anyway, I'm not going to. Okay, double number identities. Double number identities, I don't have enough time to get into those. So what we'll do is, this is what we're going to do. Thursday will be homework day. Thursday will be homework day. Thursday, I want you to work on your homework for 10.1 and 10.2. And I want you to send those questions. Some of you have already sent some. Some of you have sent chapter 9. But my priority is not 9 right now. My priority is 10.1, 10.2, 10.3. Let's see, where do y'all go? I think that's it. 10.3, but let me look right quick. I'm pulling it up so y'all can see it, like all of you did what I told you and printed out. I can't get any of my PDFs to come up. Why can't I get any of my? Can somebody look? Open in SharePoint. See if it will open in SharePoint. Okay, go away. I think it'll open now. There it is. Yeah, I thought it was 10.3. So that's my goal. My goal is, let me just write this down. My goal is to get y'all through 10.3 because 10.1, 10.2, and 10.3 is 80% of the Unit 3 test or whatever unit we're on. Okay? That's 80% of your test. So if you know those 3 sections, the highest grade you can make is an 80 on your test. And the only thing I'm going to ask you to do on the chapter 9 is I might ask you to graph something, or I might ask you what the phase shift is looking at a problem. That's the only thing I'm going to ask you. So I don't want you to fret over 9.6 and 9.7. I want you to fret over these. Okay? All right, let's finish up with the roll. And let me make sure I've turned on the homework for 10.1 and 10.2 and all that good stuff. Main menu, assignments. Yeah, there's 10.1, 10.2, and 10.3. So they're on. Okay, so that's done. Let me turn off the recording.